In this video, we will look at new features in the generic oData service interface in HANA SPS 6. So let's start by creating a simple oData service. This should just be reviewed since nothing about the creation process has changed between SP5 and SP6. I want to use the user table that we've shown in previous video demos where we first created the table using CDS, and then we used outbound connectivity from server-side JavaScript to go get some additional data from an OBOT-based system and put that data into this user table. And if you remember our user table in our SP6 demo schema, just look at the fields that it has. We've got a personnel number, first name, last name, and email. And if we look at the content, we already have 2 records in there. So let's create our oData service now. So just create a new file inside our services folder. Let's name that user.accessOData. And I've already paired this content. Creating an oData service is very simple. I basically just have to give it the name of a database table or view that contains the content that I want to use as the source of my service. And then I give it an entity name. So I'm going to take my details table, and inside my service, it will have the entity name of users. So we'll just go ahead and activate this. So now let's open my web browser so we can test this service. Put in the host name and port of my HANA server and repository path leading to my service, SP6 services, user.accessOData. Ask me for authentication. I see my entity listing, so users. If I add $sign metadata, then I get introspection on the service. I can see personnel number, first name, last name, email, the data types, and lengths. And then, of course, if I add the entity itself, then I see my data. So there's my 2 records, or if I wanted, prefer to see them JSON format. There's the data in JSON format. Now, the new feature that we want to highlight in SP6 is that oData services are no longer read-only. They now have create, update, and delete operations as well. And in fact, without any additional changes to the access oData file, the services immediately support those features. Now, of course, a security check is still done for the authenticated database user to make sure that they're authorized to perform those operations. We don't have to do any additional coding to this service in order to have the create, update, and delete operations supported. So what I want to do now is I actually want to insert a new record via my oData service. For this, I'm going to use another Chrome add-in. One that's called Postman. Now, Postman is pretty nice. It lets you basically format and build request objects. So it's a great testing tool for being able to call services. So I brought up the Postman tool. Now it remembers my URL from a previous test attempt. But maybe when you first come in here, you might have to type in the URL. In fact, I need to adjust my URL. So SP6 services user. So you see, I'm just putting the URL to my oData service with the entity. I did change it to be a post. My basic authentication. So I can build in my username and password. Make sure I spelled that right. and then it will go ahead and build your authentication into your header, and there's other types of authentication supported. You do have to set the content type to application JSON, character set UTF-8. JSON is the only format supported for the create, update, and delete operations. And then from this point, I really don't have any additional URL parameters or headers that I need for the create operation. The create will be a post. You just want to make sure that you have a post instead of a get. And then in the body itself, we'll do a raw body in the form of JSON. And I've already typed in that I want to insert a new record. And this is going to be the personnel number, and be test, dummy, and so forth. Now that I have this all ready, I will go ahead and send. So it just sent that to the server, and now we can go back to our table, and we'll just have a look at the contents in the table, and you see our record has now been inserted into the database table. And after confirming that the record is there in the system, I can also come back here to Postman, and I can see that I could have checked it here as well. I got a 201 created, the new record has been inserted, and I have a view of the response body that came back, and it gives me the unique URL for this new record that has been inserted, which data was inserted. I'm actually wanted to just copy that. It's okay. I can do a get, and what I really want is this part of the URL that says users and then loads this particular record. Because what I want to do now is I want to update this record. So to update it, I need to change my URL to point to the record that we want to update. There we are. So users, but then this this personnel number, so this key, and post will do a create, but put will do an update. So I'm going to change it to put, and then I'm just going to change some of the data here. So instead of email being test.dummy@sap.com, just change this to gmail.com. So we'll go ahead and do our send. And we'll go back to our system, do a refresh, and now you see that that record has changed. Now maybe we wanted to do a delete operation. That's very similar. Once again, we need the URL to point to a particular record. So let's go ahead and delete this dummy record. We change the verb from put to delete, and then we remove the JSON from the body. We don't need any body details. Everything we need is in the URL. So we'll go ahead and send that. And our delete has been processed. Let's go ahead and refresh. And now the record is gone from our table. But maybe you have a situation where you have a service that, even though the user connected to that service has authorization, you don't want to allow one of the operations, create, update, or delete, via the oData service. Well, that's simple enough to control as well. We can simply add to the service definition, create forbidden, update forbidden, or delete forbidden, or any combination of these. So now I've actually made all 3 of the new operations forbidden for this service. Just go ahead and activate that. And now if I would return to Postman and I would try the previous operations, let's go back to our post operation and try to recreate this record. There we are. So that's the other nice thing about Postman, is it actually remembers your previous commands. So I can go back to one. So I want to go back to this post that I did earlier and try it again. I'll hit send, and now I got 403 forbidden. So it's letting me know that modifications are forbidden according to the rules that I put into this oData service. And just to double check, we'll look at the content again, and no record has been added this time. Okay, well, let's re-enable all the operations on our service again. There we are. Now you may be thinking that, wow, this is really easy. I've got create, I've got update, I've got delete. But what if I want to write a little bit of logic before those operations are performed? Maybe I want to do some validation before I go inserting records into the database. That's perfectly fine as well. There's a nice little exit mechanism in the oData create, update, delete services, so that you don't have to write all the logic, but you can just write some simple validation to process before the operation is actually performed. And this is an exit mechanism, so the generic oData service will exit out to a SQL script procedure that you define. So let's see how this works now. I will create a new SQL script procedure. So I'll use the new wizard that we have, and I'll just name this. I'll name it users create method. So this would be called on creation. There we are, user create. And I need a little local type. So type error as table. And I want to fill in the status code as an integer. And error message varchar 100 and detail varchar 100. Here's my type. And then in my procedure itself, I want an input parameter to represent the row of data that's coming in. And this will get my catalog. Just going to reuse a type that was, oh, I'm in the wrong schema. I'll reuse the type. Well, I need to create that type real quick. So you don't want to watch me create that type, so I'll kind of do it off screen and then I'll show it to you. Actually, what I decided to do here, rather than create a whole nother type, is I'll just reference the table itself, which was generated by the CDS. So that will create the structure of my input row, and then my table type, my local table type, will be the output. And I set my default schema to be my SP6 demo schema as well. So now I'm ready for some logic. Okay, so I need to insert some code, which I've already prepared, and we'll walk through that in a second. But the next thing I need to do is, right now with this read SQL data as, this is a read-only procedure. So I need to comment that out. I still need my as statement, and that will turn it into an update enabled procedure. Now next I have just a little bit of simple logic here. So I'm going to declare some local variables. I'm going to select the data from the input row. So that's how I read the data that's coming from my input parameter. I'm going to do a little check. If the email is blank, then I'm going to produce an error message. So I just want to do a little validation that even though the email isn't part of the key field, I want to make sure that it's never empty. So some business level referential integrity there instead of something that's represented in the database itself. So I do that check. And this is how I can fill the error message. So I do a select on these literals and put them into this error. So you see in SQL script, the read operations even on variables are done via select statements. And then if the email is good, that's the only check I really have, then I'm going to insert this into the database. Now, realistically, I probably want other checks. I maybe want to check for, duplicate keys and things like that and report back a nice detailed error message rather than let the system catch it. But for the purposes of learning, I want to keep this exercise very simple, and I think this does a nice job of it. You can see you actually perform the insert operation, so if you needed to trigger other operations, you want to also record into a log or any number of things that really you have complete control of the operation at this point, but you don't have to worry about the processing of the body object or the headers or anything like that. That's all handled for you by the oData service. So let's just go ahead and save, and we'll activate. And we now have our procedure ready to be the exit procedure for this oData service. So now let's go back to our oData service definition, and we will extend it so that the create operation will pass control off to our procedure. So we'll just say create using, and then sp6.procedures, and then users create method. So that will point to my procedure. And just need to on the end, save, activate. All right, now we're ready to test again with Postman. So I'll go back to my Postman entry, and we want to do our create operation. So users with a post. Here's our record that we want to insert, but this first time let's make the email blank, and I'll do a send, and we should have gotten bad request, invalid email, email field cannot be empty. So this is the detailed error message that we built in our procedure. So email field cannot be empty, invalid email. Maybe I'll prove it to you here. I'll just make a little change. Reactivate my procedure. So now it should say no way, email field cannot be empty. And let's resend. And now you see no way, email field cannot be empty, just to prove to you that I didn't have some error message already hard-coded in my system or something like that. It's really executing the SQL script procedure. Now let's go ahead and add a valid email address, or maybe even before that, let's just let me just prove to you that it's really not inserting the record. Yep, see there. And now let's go back here and let's add this test.com, and we'll go ahead and we'll do our send. This time it's successful, and if we go back, refresh our table, and there is our entry in our table. So hopefully this has shown you how powerful the create, update, and delete operations of the generic oData service framework are, how easy they are to use, and how quickly you can be up and running with this with your existing services, but also how powerful it is to be able to have this exit mechanism, to be able to control the validation as well as the insert itself. This is really just the tip of the iceberg as far as what you could do in this exit mechanism, and then you can really concentrate on just the operation itself and not all the logic that you would have to write to handle the the headers and the response object and parsing of the content as it comes in. You can see that's all taken care of for you by the generic oData service. So I think this is a really great addition to the functionality that we have in HANA native development.